Needle experiment. Particle reflection, but not wave interference. Double experiment with slits and needles. Use of the experiment to analyze material surfaces. As exposed in the first drawing, I understand that the particles are not waves, and therefore we analyze this experiment and the experiments of simple and double slit in an impartial and complete way, because we may reach this conclusion. What then is light? Well, material particles that are rejected or reflected by the surface of the needle in this experiment and by the interior surfaces of the slits in the case of the simple and double experiment with slits, but in no case waves that interfere with each other. Needle experiment. Preamble, drawing. In the traditional experiment, the plate with slits represents a total flat cut of the emission of the light ray, leaving only those slits as a surface of penetration and impulse for that ray, that is, a minimum of the potential carried by the ray. However, the completely circular shape of the needles allows the compression and passage of almost the total potential of the ray, since they could approximate the shape of a double funnel, where the ray is first compressed at the entrance and then expanded at the exit. So whether the light ray is simple material particles or waves, in both cases its passage would be facilitated with a much higher potential than in plates with slits. And in the case of particles, the round shape of the needles would allow a large and extensive reflection of them, up to 360 degrees, depending on the assembly and number of needles used, and only very small and almost imperceptible additional reflections caused by the inner surface of the needles, as it really happens. But what is not observed are those clear wave interferences that should exist as a result of the powerful penetration of the light ray between the needles, replacing that great reflection of the continuous light ray that is observed throughout the circular contour of the experiment. Now well, in this experiment you can use a bright beam, or a laser as in my case, and of course, a needle on which the laser and a screen where the signals are collected. Then, something similar to the experiment of simple and double slit, but this case with a needle instead. And to make the experiment useful, the needle must have a diameter similar to that of the lightning, or laser we use. If the lightning is much smaller than the needle, then only the laser will be marked on the needle, and the contour of it will be perfectly seen. Of course, they will not produce that supposed wave that makes up the light and that would produce interference behind, on the screen. If the thickness of the needle is similar to that of the lightning, then a small needle neck will begin to glimpse on the screen signal, caused by the sides of the lightning begin to overflow the needle on the sides and compress the sign. If the needle is much smaller than the diameter of the laser, then the sides of the latter will overflow it on the sides, and the needle neck will decrease in the signal, ending by cutting and disappearing the needle completely and only appears only the laser signal and particle reflection. Now, and I repeat again, there are no wave or interference signs, only particle refraction. Reflection in the needle and slits. If the light were waves, then this when arriving at the needle would be split in two, producing from here double waves with its corresponding interference, and all this, whatever the diameter of the needle. But it does not, because there is no luminous wave but the light particle, in my opinion, of course. On the other hand, the reflections of the particles on the needle and on the inner parts of the slit seem clear. In the needle, because it is circular, because the laser expands in the form of almost complete circle, at least 120 degrees on each side. On the other hand, in the slits as seen in the drawing, there are only small reflex surfaces inside the slits, which produce only very small signals to the sides of the main laser. Analysis of needle materials and their reflex signs. A circumstance that I have observed is the logical importance of the materials that the needles are made when it comes to reflecting the light. Reflective material needles such as steel, as they produce a large light signal and an extensive field of reflection. In changes the somewhat opaque or rough surface materials such as wood, etc., give little field of reflection and little intensity of it. I have done some wool thread test, and there has been an interesting reflection in the form of star ramifications. Therefore, I think this method could be used to analyze materials through the light reflexes they produce. Double experiment with slits and needles. I have also carried out a mixed experiment with needles creating the simple and double slit. Here I expose a photo using simple and double slit, which would demonstrate that the light is not waves, but only particles. In this example, 2 thick wood needles are used that have little defined the reflexes, and a central steel needle that does produce the expected reflexes of this material. If the needles were the 3 of steel, the sides could produce some additional reflexes such as those that occur in the traditional and double slit experiments. Therefore, the additional signals that can occur in some circumstances are due to particle reflections and not to the interference of waves. Well friends, as a summary of this experiment, I think it is enough for now. We will continue with it. Thank you so much.